Okay, Assalamualaikum warahmatullahi wabarakatuh. Introduce myself. My name is Burhanuddin. I from STT Warga Surakarta, Sekolah Tinggi Teknologi Warga Surakarta, as the first author. And then the second author is Mr. Triwidodo Besar Yadi from University of Muhammadiyah Surakarta. And the third author is Mr. Ignatius Hendri Adinagoro from Sekolah Tinggi Teknologi Warga Surakarta too. And the fourth author is Mr. Agus Samaldi from Sekolah Tinggi Teknologi Warga Surakarta. In this session, I will present our research about splitting lead effect on cutting lips, twist drill to spindle torch, chip morphology, and surface roughness on S45C drilling process. One of the problems in conventional drilling is the evacuation of chips out of the drill hole. If the chip products in the drilling process cannot be evacuated, the chip will get caught in the drill bit so that it will rub against the drilling wall. Galloway demonstrates that very small variation in drill bit geometry can have a very significant effect on drill bit performance. Makoto Gawa, who made the splitting nick on the cutting side of the lips twist drill to break up the chip that came out the drilling process, although the research result in lower drilling torch and better surface finish, but the problem of chip length has not been solved. The rectangle design also plays an important role in evacuation chip in drilling process because it effect in chip breaking, say Susanta. Jeff observed that drilling with chip breaker grooves was effective in reducing chip length. Chandra's research showed that there is good potential for the insertion of obstruction pins on the float space of the drill bit to obtain a controllable chips. From the research conducted by Santo, Jeff, Chandra, and Makoto Gawa, the easiest modification to do is the modification made by Makoto Gawa. The simplicity of the modifier twist drill so that it can be widely applied in the machining world and produce good drilling result is very necessary. However, in Makoto Ogawa's research, the effect of comparison of the number of splitting niche on the drilling process has not been studied. The purpose of this research is to make splitting niche on the cutting lips twist drill and to vary the number. The success rate of cutting lips modification from several configurations of the number of splitting niche on twist drill is measured by determining the machine spindle load during the drilling process, chip morphology, and surface roughness of the drilling results. In preparation, the first step is to make a splitting nick on the cutting lips drill bit with a universal machine drilling tool. The drill bit specimen in this study are the uncoated drill bit with a diameter of 14 millimeter. The grinding stone used is grinding stone with disc-shaped aluminum oxide abrasive granules. The dressing and throwing process is carried out on grinding stones to ensure the sharpness and angle of grinding stones 30 degrees. Furthermore, grinding stone applied to make splitting nick with a depth of 1 millimeter and standing and turning angle of 9 degrees from cutting lips drill bit. Figure A shows the angle of the grinding stone and B, the angle of tanning and cutting lips, and C, the example of the result of tanning on the drill bit. The figure is actual figure at the universal grinding machine to prepare grinding wheel and grinding process to make splitting nick and cutting lips twist drill. Specimen twist drill without splitting nick and with splitting nick. So at this figure that the modification result of the variation in the number of splitting nick in the drill bit. So in this figure. H-series drill used for drilling has 45C material with a depth of 35 millimeter. The cutting parameter shown in this table that fit rate 100 millimeter per minute, and spindle speed in RPM 1454, and fit party 0.11, and cutting speed is 20 in millimeter per minute. And the drilling process creating be using the CNC milling Billy CV 1060 engine with control Mitsubishi M70. This machine has the advantage to display the large spindle load of its cutting process on the operation of the engine that's converted into a torch spindle. The workpiece test is as 45C materials. The drilling method used is the back drill, in which every drill with a depth of 10 millimeters, the drill bit rises above the workpiece to remove the chips. This is when chip data collected. The drilling program is shown in the picture. And then result and discussion, the chip form drilled material using three model of variation splitting nick. So in the picture. In the figure A, shown the shape of the chip drilling using the first drill without splitting nick, like that. The resulting chip is in the form of a long angular thick helical chip. According to clock, the long chip shape will cause accumulated chip and cause it to be difficult to evacuate, while the helix shape chip tend to come out through the flank face, thus causing damage to the cutting and cutting edge holder. And picture B shows the shape of the drilling chip using the second drill bit with two splitting nick on one side on the cutting lips twist drill and one splitting nick on the other. The resulting chip shape is a long angular thick helical chip and long angular loose helical chip with a smaller width. The shape of bit of this smaller chip allows easier evacuation from drilling holes. Picture C shows the shape of a drilling chip that uses a third drill bit with those splitting nick on either side of the cutting lips. And then torque value when drilling in Newton meter and comparison graph of the value of the spindle torque of each drill bit. The measurement result of the spindle load converted into torque value are shown in the table. Torque value result show that splitting nick on the second drill bit, and third result in lower torque spindle values compared to drilling without splitting nick. The second and third drill bit products chip are easier to evacuate and don't interfere with the cutting process. The drilling without splitting nick generate along with chip and from a thick helix. It makes it harder to get out of the drilling hole. And surface roughness value of a drilling hole in micrometer. So in this figure, that the average value of the roughness of the surface of the tree drilling process performance is shown in the table. While the cross section of the drilling hole was shown in figure, the measurement results show that the splitting nick was very influential on the roughness of the surface progress in the drilling process. The level of surface roughness in the second drilling is smaller than in the first and third drilling. Found that the third drilling product spiral scratch. Look at the figure C. On the drilling hole wall that caused the third drilling wall to be rounder compared to the first and second holes. The shape of the chip that is too flat and long makes it difficult to effectuate so that it scratches on the wall of the drilling holes. And then the last conclusion, the results show that giving splitting nick to cutting nips twist drill can improve the shape of chip in drilling process to be slimmer and facilitate the process of evacuating chip from drilling holes. As a result, the spindle loads and drilling torques become lower, and the roughness of the drilling hole wall surface is also smoother. Okay, thanks for attention. Assalamualaikum warahmatullahi wabarakatuh.